Okay, so today we're going to be talking about mixed expressions and complex fractions. Our main idea for today is to simplify mixed expressions and complex fractions. And this comes from Standard 12 and 13. So, recall back from your elementary school days, mixed numbers. This again is a sum of an integer and a fraction. And so here's an example. We have 2.5. We can rewrite it as the sum of an integer and a fraction. Okay? Today we're going to be taking a look at mixed expressions. And this is the sum of a monomial and a rational expression. And here is an example of one of those. Note the integer here, or the monomial, and the rational expression. Remember that a rational expression is a fraction with polynomials in the numerator and denominator. Okay? So we're going to take a look at how to simplify these. Okay, so recall that when we have something that looks like this, 2 plus 1/2, we can rewrite 2 as a number over 1 and add 1/2 to it. Okay, and note that we cannot add them as it is because they do not have the same denominator. So when that happens, we have to make sure to find the lowest common denominator and change the fraction so that they both have the same denominator before you can add them. So here we note that our lowest common denominator is 2, and so if we are to multiply this denominator by 2 to make this denominator 2, we need to multiply the numerator by 2 as well. Okay, so we now have 4 over 2 plus 1/2, and now we can go ahead and add the numerators. And so we get 5 over 2. Okay, so we use a similar method when we're dealing with mixed expressions. Okay, so when we have 3 plus x plus 2 over x minus 3, we can go ahead and rewrite our monomial here as a fraction over 1. Okay. So now when we have this, we can't add them right away, right, because they have different denominators. So we have to make sure to change one of these fractions, or both, so that they have the same denominator. So if we find the lowest common denominator, in this case it would be x minus 3, we would have to multiply both the numerator and the denominator by x minus 3. Okay, so now we have 3 times x minus 3 over x minus 3. We're going to go ahead and rewrite this next to it. Okay, so now once they have the same denominator, we can go ahead and add the numerators. So this becomes 3 times x minus 3 plus x plus 2 all over x minus 3. Okay, and we can go ahead and simplify this. And so distributing, we get 3x minus 9 plus x plus 2 over x minus 3. And simplifying even more, 3x plus x gives you 4x, minus 9 plus 2 gives you a negative 7, and that's all over x minus 3. And we have our final answer. Okay. So now let's take a look at another example. Okay. We have p plus 4 plus p plus 1 over p minus 4. Okay. So we're going to do the exact same thing. We're going to place that first monomial or first polynomial over 1. So that's p plus 4 over 1. And we're going to add that to p plus 1 over p minus 4. Okay. And again, since they do not have the same denominator, we have to make sure to find the lowest common denominator and adjust the fractions accordingly. Okay, so least common denominator is p minus 4. So we have to go ahead and multiply, since this already has p minus 4 as a denominator. We're going to move on to this fraction. Multiply both by p minus 4 over p minus 4. So that becomes p minus 4 times p plus 4 over p minus 4 plus p plus 1 over p minus 4. Okay, so now we have the same denominators, and we can go ahead and add those numerators together. Okay, so I'm going to go ahead and rewrite this as the sum over the same denominator. And then we can go ahead and simplify this by FOILing. Okay, that gives us p squared, 4p minus 4p gives us 0, and negative 16 plus p plus 1. Okay. And then we can simplify it even further. You can write it in descending order. Negative 16 plus 1 gives you a negative 15 over p minus 4. Okay. And that is your final answer. Okay, so now I'd like you to go ahead and try page 623, number 15, and bring that to class tomorrow so we can check on that. Okay. Now we're going to go ahead and move on to complex fractions. Okay. Complex fraction is a fraction that has one or more fractions in the numerator or denominator. Okay, so again, flashback to elementary school, where we see a numerical example of that. 8 over 3 divided by 7/5. And then we have an algebraic example of this, which is what we're going to work with more today. X squared y squared over a divided by x squared y over a to the third. Okay. So we're going to take a look at how to actually simplify both of these. Okay. So you'll recall that in order to simplify these, we're going to 1. Rewrite as a division problem going across. Number 2, we're going to rewrite it as a multiplication problem by the reciprocal. Okay, so we're going to flip the second fraction. And number 3, we're going to multiply and simplify. Okay, so let's take a look at that in action. I'm going to take a look at that first example. So when we have 8 over 3 divided by 7/5, we're going to rewrite it as a division problem. So that's 8 divided by 3 divided by 7/5. Okay, so that's step 1. Okay, step 2, we're going to go ahead and rewrite it as a multiplication by the reciprocal. Okay, so that's 8/3, and we are now multiplying it now. And when we take the reciprocal of the second fraction, we're going to flip it. Okay, so that becomes 5/7. Okay, and now we can go ahead and multiply and simplify. So 8 times 5 gives you 40, and 3 times 7 is 21. Okay, So we can apply those same steps to simplifying something that looks like this. Okay? So when we have x squared y squared over a divided by x squared y over a to the third, our step 1 is to rewrite it as a division problem going across. So we can go ahead and rewrite it as so. Okay? So once we have that, we can go ahead and rewrite it as a multiplication by the reciprocal. That's step 2. So that becomes x squared y squared divided by a, and now it's a multiplication problem by the reciprocal. So we're going to go ahead and flip the numerator and denominator. Okay, so now we can go ahead and multiply and simplify. So we have x squared y squared divided by a times a. Okay? So now we can go ahead and cancel any common factors that we might find. Okay? So you'll note that there's an x squared and an x squared in both the numerator and denominator, so we can go ahead and cancel that out. Okay. I'm going to rewrite this as y times y since we have two y's here. Okay, and note that since we have one y in the denominator and 2 here, we can cancel 1 and 1, so that leaves us with 1 y still. Okay, and with the a's, I'm going to go ahead and rewrite that as a times a times a. Okay, so that's a cubed, and there's 1a in the denominator that we can cancel with the numerator, so we're still left with 2 a's. Okay, so since we have 2 a's left over, that's a squared, and we have a y, and we have just a 1 in the denominator. So to simplify, we have a squared y. And that is your final answer. Okay? Okay, here's another example that we can look at. We're going to go ahead and apply those same steps. Okay, so I'm going to go ahead and rewrite that on the side. So we have x minus y divided by a plus b, and that's divided by x squared minus y squared over a squared minus b squared. Okay, so that was step 1. Step 2, we can go ahead and rewrite that as a multiplication problem. Okay, so x minus y over a plus b multiplied by its reciprocal. So that's a squared minus b squared over x squared minus y squared. Okay, and then we can go ahead and multiply and simplify. Remember our steps for multiplying. We want to make sure to factor anything that we can factor here before going ahead with our usual steps. Okay, so x minus y is already in its simplest form, so is a plus b. What about a squared minus b squared? Does that look like something familiar that we factored? It's a dots, right? So I'm going to go ahead and rewrite this here first. And since this is a dots, we know that we can factor it like so. Okay. And the same with the denominator. X squared minus y squared is also a dots. So that can be rewritten as x minus y times x plus y. Okay, I'm going to go ahead and make sure that these are within the parentheses so we don't get confused about what we can and cannot cancel out. Okay, so we can go ahead and extend that bar, and then we can cancel out any common factors. Okay, so we see an x minus y in the numerator and an x minus y in the denominator. There's an a plus b, and a plus b, and is there anything left to cancel? Nope, so we are just about finished. That's a minus b over x plus y. And that's your final answer. Okay, so I want you to go ahead and try out page 624, numbers 25 and 29, and bring that to class tomorrow. And we're going to go ahead and take a look at one last example. What if you have something that looks like this, where we have a mixed expression in a fraction here? Well, it's not going to be too different. All we need to do is simplify our mixed expression first before we go ahead and continue to divide. Okay? So let's take a look at how that works. Okay. So since we can rewrite the numerator as a is a fraction over 1 minus 15 over a minus 2, and all of that is over a plus 3. Okay, so we're going to focus on that numerator first, and we're going to simplify that. Okay, so if we take a look, when we simplify that, we have to make sure that those denominators are the same. So we find our least common denominator, which is a minus 2 in this case. Okay, so we multiply both the numerator and the denominator by a minus 2. Okay, so that becomes a times a minus 2 divided by a minus 2 subtracted by 15 over a minus 2. Move that over. And that's all over a plus 3. Okay, so let's go ahead and simplify this. We're going to go ahead and rewrite this as subtraction all over a minus 2, since they have the same denominator now. Okay, again, that's all over a plus 3. Okay, simplifying even further, we're going to go ahead and distribute. So that's a squared minus 2a minus 15 all over a minus 2 divided by a plus 3. Okay, so now once we're at this point here, we can go ahead and rewrite it as a division problem. So we're moving into step 1 again. Okay, so I'm going to write this here. So that's a squared minus 2a minus 15 over a minus 2 divided by a plus 3, and we can write that as a fraction over 1. Okay. Step 2, we're going to multiply it by its reciprocal. So that becomes a squared minus 2a minus 15 over a minus 2 multiplied by, flip it, 1 over a plus 3. Okay, so now once we have that, we can go ahead and multiply as usual. Okay. see if we can factor this. Okay, so this can factor to be a Does that work? A Okay. So now once we factor the top, we can go ahead and extend that fraction bar and cancel any common factors. Okay, so there is an a plus 3 in the numerator and denominator, so we can cancel those. And we are left with a minus 5 divided by a minus 2. Okay, and that is our final answer. Okay, so lastly, I want you to go ahead and try page 622, number 4B, and bring that to class to discuss. And that's it.